Okay, so you want to get up to speed on using the Livy API with Microsoft Fabric. Buckle up because we're diving into some seriously cool tech. It sounds like you're ready to level up your Spark game, and you've come to the right place. We're going to break down this seriously cool tech using the documentation and articles you've provided. It's all about streamlining your Spark jobs and having more control over how they run. We've got Microsoft Learn articles and even some Apache Livy documentation to guide us. Let's dive in.
Sounds like a plan.
All right, the Microsoft Learn articles highlight that the Livy API is specifically designed for data engineering in Microsoft Fabric. So tell me, what's so special about it? What makes it stand out from the usual ways of working with Spark?
What's fascinating here is how the Livy API changes the way we interact with Spark in Fabric. Instead of going through notebooks or Spark job definitions, you can submit code straight to the Spark compute engine that's linked to a lakehouse.
Imagine the possibilities.
Wait, directly to the compute engine? That sounds like a pretty big deal. Does this mean it works directly with data stored on OneLake too? That's exactly where the real magic happens, that direct connection. Yes, you hit the nail on the head. The Livy API seamlessly integrates with OneLake, so your data is right there, ready to go. No more moving data around or juggling different systems.
Okay, that's starting to make sense.
Hmm?
The articles mention two ways to use the Livy API, session jobs and batch jobs. I'm guessing they're not the same thing, right?
You're right. They serve different purposes. Think of session jobs as an interactive chat, where you establish a connection and send multiple commands, building on the results as you go. This makes them perfect for interactive analysis, like when you're exploring data or developing code.
So kind of like working in a Spark shell, right?
Exactly. On the other hand, batch jobs are more like sending a single self-contained message. You submit your code, it runs, and you get the result. No back and forth. This is ideal for automated tasks, like running a data processing pipeline overnight or performing large-scale transformations.
So session jobs for exploration and experimentation, and batch jobs for automation. That makes sense. Now, while I was going through the Apache Livy documentation, I stumbled upon something about impersonating users. It mentioned a do-as feature. What's that all about?
That's a really important security feature. Do-as allows administrators to control which user identity is actually used to execute the code submitted through the API. It's like an extra layer of protection, especially in environments where multiple people are using the same system.
So even if multiple users are submitting jobs, you can make sure that the code runs with the right permissions and access controls.
That's right. It's all about ensuring security and accountability.
Okay, so let's say I'm all set to use the Livy API. I've got Visual Studio Code open and I'm ready to go. What are the actual steps involved in making this thing work? The articles mention some code examples, but I could use a bit more clarity on the process.
The Submit Spark session jobs using the Livy API article actually provides a step-by-step guide. The first step is getting an Azure Active Directory app token. This acts as your authentication key, proving you have the right to use the API.
Right, the Azure AD app token. So once we have that token, what's next?
Then you need to target the specific Livy API endpoint for your workspace and lakehouse. This endpoint acts as the entry point for your code submissions. Once you've hit the correct endpoint with the right token, you're good to go.
And then, boom, my Spark code is on its way to the compute engine.
Exactly. It sounds complicated, but once you understand the flow, it's quite straightforward.
Okay, that's reassuring. But let's be real. I'm bound to make some mistakes along the way. How can I check if things are running smoothly? The articles mentioned a monitoring hub. Can I use that to track my jobs?
Absolutely. The monitoring hub is your best friend when working with the Livy API. You can see the status of your jobs, get detailed logs, and even check which version of Spark and what configurations are being used. It's like having a window into the execution of your code.
So I can see if my job is running. Check for any errors and make sure everything is configured correctly.
Precisely. It eliminates a lot of the guesswork and gives you a much better understanding of what's going on behind the scenes.
I'm starting to see the appeal here. Being able to send Spark code directly to the compute engine, having those security features in place, and being able to monitor everything closely sounds pretty powerful. But what about the actual code I send through the API? Is there a specific format it needs to be in?
You're right. The format is crucial. You need to package your code within a JSON payload. It's essentially a structured way of sending information to the API, including your code, the type of job session or batch, and any specific configuration you want to apply.
A JSON payload. So it's more than just pasting my code directly. What kind of code can I actually send? Is it limited to Spark SQL? Or can I use other languages like PySpark or Scala?
The Livy API is quite versatile. You can send various types of code, including Spark, ClickLot, PySpark, and even Scala. You just need to specify the kind of code within that JSON payload so the API knows how to handle it.
That's impressive. Having the flexibility to use different languages definitely opens up the possibilities. So it's not just about sending the code, but also telling the API how to interpret and run it.
Exactly. You're in control of the code and how it's executed.
This is getting more and more interesting by the minute. I'm starting to grasp the potential of the Livy API. We've covered quite a bit already. Session and batch jobs, security features, getting started with Visual Studio Code, using the monitoring hub, and even the structure of the JSON payload. But I'm curious, what kind of real-world applications does this Livy API actually excel at?
That's a great question, and I think it's the perfect segue into our next part. We've laid the groundwork, and now it's time to see how the Livy API is being used to solve real-world data challenges.
Welcome back to our deep dive into the Livy API. We've covered the technical foundation, but now I want to see the Livy API in action. How are people using this in real-world scenarios?
One of the most compelling use cases is automating Spark workloads. Instead of manually running Spark jobs, the Livy API lets you trigger them programmatically.
So instead of manually running my data processing pipeline every night, I can set up a script to do it for me using the Livy API.
Exactly. That's a perfect example. You could schedule a batch job to handle your data transformations, load the results into a Delta table, and even get a notification when it's finished. No more late nights babysitting your Spark jobs.
Okay, I'm liking this already. This automation aspect seems like a major time saver. But beyond just automating tasks within Spark, can the Livy API be used to connect Spark with other systems?
Absolutely. Think of a data pipeline where you're pulling data from a streaming source, processing it with Spark, and then storing the results in a database. The Livy API can orchestrate that entire workflow, seamlessly connecting all the different pieces.
So it's like the Livy API is the conductor of my data orchestra, ensuring all the instruments play in harmony.
That's a great analogy. It's all about creating a unified data flow, bringing different technologies together seamlessly. And speaking of bringing things together, what about using the Livy API for machine learning tasks? Could I use it to train and deploy models?
Now that you mention it, the Submit Spark batch jobs. Using the Livy API article did have an example of using a Python script for data cleaning and creating a Delta table. That seems like a good fit for batch processing.
You're right. That's a classic batch processing scenario. And yes, you can definitely use the Livy API for machine learning. Imagine submitting a Spark job that trains a model on a massive data set. Once the model is trained, you could even use the API to deploy it as a REST endpoint for real-time predictions.
So I wouldn't be limited to just running the training job. I could actually manage the entire model lifecycle, from training to deployment, all through the Livy API.
Exactly. It bridges the gap between data engineering and machine learning, allowing you to create and manage end-to-end solutions more efficiently. This brings a whole new level of flexibility and control to machine learning workflows.
It's starting to feel like the Livy API is more than just a way to run Spark jobs. It's like a fundamental shift in how we approach data engineering and data science.
I agree. It's about breaking down traditional silos and giving developers more powerful tools to extract real value from their data.
Okay. So we've seen how the Livy API can automate workloads, integrate with other systems, and even handle machine learning tasks. Is there anything it can't do?
It's important to remember that while the Livy API is extremely powerful, it's not a one-size-fits-all solution. There are still situations where other tools might be a better choice.
Like what kind of situations? When would I want to use something else?
For example, if you need a highly visual and interactive environment for data exploration, a Spark notebook might still be more suitable. Or if you're dealing with a complex workflow that requires a lot of custom logic and branching, a dedicated orchestration tool might be a better fit.
So it's about choosing the right tool for the job and understanding the strengths and limitations of each approach.
Exactly. Each tool has its place in the data ecosystem.
That makes sense. It's all about finding the right balance between power, flexibility, and ease of use.
Yeah.
But shifting gears a bit, the Submit Spark session jobs using the Livy API article also mentioned that you can submit individual statements to a running Spark session. Does that mean you can use the Livy API for more interactive tasks as well?
You're right. We've mainly focused on automation and batch processing, but the Livy API can also be used for interactive data exploration and analysis. You can think of it like an interactive shell, where you send snippets of Spark code and get immediate feedback.
So I could use a Livy API to experiment with different data transformations, run ad hoc queries, and basically play around with my data without having to spin up a full-blown notebook.
Exactly. It's a great way for data scientists and analysts to quickly explore data and get hands-on with Spark without the overhead of a notebook environment.
That seems incredibly useful for quick prototyping and exploratory data analysis. It's like having the best of both worlds. The power and flexibility of the Livy API, combined with the interactivity of a Spark shell.
It is a versatile tool, but with all this talk about flexibility and automation, I can't help but think about the importance of monitoring and logging. When you're running Spark jobs programmatically, how do you make sure things are running smoothly?
You're right. Visibility is key, especially when you're not manually monitoring every step of the process. We talked about the monitoring hub earlier. Is that enough?
The monitoring hub is a great starting point, but for production-grade data pipelines, consider setting up your own logging and monitoring systems to capture more detailed information about your Livy API jobs.
So I shouldn't just rely on the built-in tools. What kind of additional monitoring and logging would be beneficial?
Think about capturing things like detailed job execution times, resource utilization metrics, and any custom events or errors that might be specific to your application. This level of granularity can be invaluable for troubleshooting and performance optimization.
Okay, so robust monitoring and logging are crucial for any serious application using the Livy API. It's not just about setting things up and hoping for the best. It's about proactively ensuring that everything runs smoothly and efficiently.
Precisely. And while we're on the topic of ensuring smooth operation, I think it's worth revisiting the configuration options available in the Livy API. We touched on this briefly, but do you remember how these options can be used to fine-tune Spark jobs?
You're referring to things like setting the driver memory, executor cores, and even specifying the Spark version, right?
Yes. These configuration options allow you to tailor the execution environment to your specific needs. It's worth spending some time understanding how these settings can impact performance, resource consumption, and overall cost.
So it's not just about sending code through the API. It's about optimizing the environment in which that code runs to maximize efficiency and performance.
Exactly. It's about getting the most out of your Spark infrastructure.
I'm beginning to realize that mastering the Livy API requires a deeper level of understanding than I initially thought. It's not just about knowing the commands. It's about thinking strategically about how to optimize and manage your Spark workloads effectively. But before we get too lost in the technical details, let's shift our focus and try to anticipate what the future holds for the Livy API. Welcome back to our deep dive. We've covered the technical details, the real-world applications, and even touched upon best practices. Now, let's shift gears and look towards the future. Where do you see this technology heading?
One trend that's particularly exciting is the growing integration of Livy with serverless scheduling platforms. Imagine a world where you can trigger Spark jobs on demand without having to manage any infrastructure. That's the promise of serverless, and I think Livy is well positioned to embrace this shift.
So no more worrying about clusters or nodes, just pure, seamless Spark code execution.
Exactly. It would be a game changer for data professionals.
Yeah.
Allowing them to focus on solving problems without getting bogged down by infrastructure management.
That sounds fantastic.
Yeah.
But I'm curious about the mechanics. How would this integration with serverless platforms actually work?
One possibility is to use technologies like Azure Functions or AWS Lambda to trigger Livy API calls. These serverless platforms can respond to events, like new data landing in a storage account, and automatically kick off a Spark job via Livy to process that data.
So it's like a chain reaction.
Yes. New data triggers a function, which in turn triggers a Spark job through Livy. It's all automated and incredibly efficient.
That's quite impressive. And speaking of efficiency, what about performance optimization? Do you see any advancements on the horizon in terms of how Livy handles Spark job execution?
Absolutely. There's a lot of research and development focused on boosting the performance of Spark jobs submitted through Livy. This includes optimizing communication between Livy and the Spark cluster, as well as improving how Livy manages resources and schedules tasks.
So we can expect even faster and more efficient Spark job execution in the future.
Precisely. And it's not just about speed, it's also about resource utilization. By optimizing how Livy manages resources, we can ensure that Spark jobs are executed using the minimum amount of compute power and memory, leading to significant cost savings.
That makes a lot of sense. Faster execution and lower costs are always welcome. Now, it's impossible to talk about the future of data without mentioning AI and machine learning. Do you see Livy playing a role in that space as well?
You're right. AI and ML are becoming increasingly important, and I believe Livy will play a crucial role in their integration with Spark. We've already discussed how you can use Livy for machine learning tasks, but I think this integration will become even deeper and more seamless.
So we might see Livy evolve into the go-to API for deploying, managing, and even monitoring AI and ML models built on Spark.
That's certainly a possibility. Imagine being able to train a machine learning model using Spark, deploy it as a REST endpoint using Livy, and then monitor its performance all through a single unified interface. That's the kind of power and flexibility Livy could offer in the future.
That's a compelling vision. It sounds like Livy has the potential to be a truly indispensable tool for anyone working with data in the age of AI and ML.
I agree. And as the technology continues to mature, we can expect to see even more innovative and exciting use cases emerge.
This has been an incredible deep dive. We've gone from the technical fundamentals of the Livy API to a glimpse into its future potential. Before we wrap up, is there anything else you'd like to share with our listeners?
Just one final thought. Don't be afraid to experiment. The best way to learn is by trying things out, exploring different use cases, and pushing the boundaries of what's possible. The future of data is bright, and the Livy API is helping to lead the way.
That's a great message to end on. Embrace the power of experimentation and push the boundaries. Thank you so much for joining me on this deep dive. It's been an incredibly enlightening conversation.
It's been a pleasure. I always enjoy exploring the world of data and technology.
And to our listeners, thank you for joining us on this deep dive into the Livy API and Microsoft Fabric. We hope you've gained a deeper understanding of this transformative technology and are excited to see what the future holds. Until next time, keep exploring, keep innovating, and keep pushing the boundaries of what's possible with data.